New Horizons changed our perception of Pluto, from a simple cold planet to a world full of mysteries and potential underground oceans. What else does this dwarf planet hide, and could there be an underground ocean? The New Horizons mission was a true test in space, one of the most challenging in human history. When the spacecraft reached Pluto, it managed to capture images of this icy planet at the edge of our solar system like never before. But maybe we weren't the first ones. What New Horizons discovered made scientists wonder, is Pluto really just a cold, lifeless rock? Or is there something more? 8 years later, the data collected during this mission is still being analyzed by the team, bringing new exciting discoveries and changing our understanding of the solar system. Could there really be a hidden ocean of liquid water beneath Pluto's surface? What caused the formation of ice dunes on the planet? Learn about these fascinating topics, how the dwarf planet exchanges material with its largest cosmic neighbor, and more as we embark on a journey to see Pluto as never before. The New Horizons spacecraft was launched on January 19, 2006, with the goal of studying Pluto, which was then considered the most distant planet in the solar system. At the time, there was no way to view Pluto up close, and scientists were eager to see what its surface looked like. Since Pluto is so far from Earth, the mission team had to devise clever tricks to speed up the spacecraft's journey, or it would have taken too long to reach its destination. After the launch, the spacecraft crossed the Moon's orbit in less than 9 hours. As it approached the largest planet in the solar system, Jupiter, the spacecraft took images of the gas giant and its moons. On Io, it captured an eruption of the Tvashtar volcano, which shot material 200 miles into space. In 2007, New Horizons passed within 1.4 million miles of Jupiter and received a significant gravity assist from the gas giant. This maneuver shortened the time to Pluto from 14 to 9 years, although an 8-year journey still lay ahead. To keep the spacecraft's electronics in good condition, scientists put it into hibernation mode. When New Horizons was about 3 billion miles from Earth, the mission team encountered technical difficulties. At such a distance from the Sun, the spacecraft wasn't receiving enough sunlight to generate the necessary power, leading to communication problems. The situation worsened as the spacecraft approached Pluto, with its signal taking about 4.5 hours to reach Earth. About 4 months before the flyby of Pluto, the spacecraft's cameras began to reveal distinct details of the dwarf planet's surface, with the level of detail increasing every week. One of the mission's challenges was the discovery of 2 new moons of Pluto, Kerberos and Styx, which indicated that there might be much more space debris around Pluto than expected. The researchers had to figure out a way to avoid potential issues in case of a large amount of debris near the planet. The mission team had 2 backup options: to use the antenna as a shield against approaching particles, or to move closer to Pluto than originally planned, where there might be fewer debris. However, 10 days before the closest approach to Pluto, something unexpected happened. The New Horizons spacecraft went into safe mode, and astronomers lost contact with it. Fortunately, it was just a computer overload, an issue with the spacecraft's command sequence. The team quickly regained control of the spacecraft and decided to take safety measures, collecting a special set of data in case something went wrong after the spacecraft turned away from Earth for the closest flyby of Pluto. This backup data set contained images that humanity would have lost forever if something had gone wrong and this precaution hadn't been taken. No one would have ever seen that stunning image of Pluto with its famous heart-shaped spot. This compilation of images of the planet from different angles, or Charon, Pluto's moon, in vivid colors. On July 15, 2015, messages from New Horizons finally reached the mission operations base, informing astronomers that 13 hours earlier, the probe had successfully flown over Pluto's surface at an altitude of 4,150 miles, taking hundreds of images and collecting scientific data on the dwarf planet's atmosphere and its moons. But getting this data wasn't easy. If you think your internet provider's download speed is slow, imagine this. Downloading about 6.25 gigabytes took a whopping 15 months. The probe could transmit only 1-2 kilobits of data per second, all due to the vast distance between New Horizons and Earth. However, it was worth the wait. For the first time, humanity received a detailed view of Pluto's surface up close. Among other things, a mountainous terrain with peaks reaching 11,000 feet was discovered, and these mountains aren't made of rock but ice. Researchers believe that this glacial ridge is no older than 100 million years and may be evidence of recent geological activity. Another close-up image shows the surface of Charon, Pluto's moon, where signs of past landslides are visible. New Horizons also captured several impressive layers of haze around Pluto's atmosphere, extending up to 120 miles above the celestial body's surface. This haze forms when ultraviolet light breaks down methane particles in Pluto's atmosphere. Methane then turns into more complex gases like ethylene and acetylene, which the probe previously detected in the dwarf planet's air. These gases fall into the colder parts of the atmosphere and turn into icy particles that form layers of haze. This alien atmosphere tells researchers a lot about what's happening on Pluto's surface. There, sunlight turns the haze into tholins, or dark hydrocarbons, which give Pluto's surface its reddish hue. Near the largest of these dark regions is a white, heart-shaped area where a nitrogen glacier called Sputnik Planitia stretches for 620 miles. This glacier is so large that it has no equal anywhere in the solar system. Astronomers believe it's a relatively new formation on Pluto's surface and quite mysterious, as its origin remains unknown. Some researchers suggest it might be an impact crater, and strange things are happening there. One of these strange phenomena is that ice on Pluto turns directly into gas. Ice has a unique property known as sublimation. If you leave ice in the freezer for a long time, it gradually disappears. This happens because ice slowly transitions from a solid state directly to a gaseous state, skipping the liquid phase due to insufficient temperature for melting. The surface of Sputnik Planitia is covered with geometric shapes formed by nitrogen ice, which remained a mystery to scientists for a long time. One possible explanation is that Pluto's surface experiences the same effect, but ice deposits are uneven across the surface. As the ice on the dwarf planet shrinks, it creates strange polygonal patterns scattered across Sputnik Planitia, resembling ice dunes. Sublimation of ice also creates ridges or ice blades on Pluto. Something similar also exists on our planet. Scientists call it penitentes. But unlike the few meter-high ice pillars that form on Earth, on Pluto, they can grow much larger, up to the size of skyscrapers, reaching hundreds of feet tall when methane freezes and evaporates during warmer periods. This freezing and evaporating process has been going on for millions of years, deforming the ice and giving it blade-like shapes. Another mystery of Sputnik Planitia is its location. Scientists believe this region might have migrated across Pluto's surface in the past. They call the process behind this polar wandering, and if the scientists are right, Sputnik Planitia might be responsible for the dwarf planet's rotation. The famous heart-shaped region on Pluto has a positive gravitational anomaly. The gravity there is different from all other regions on Pluto's surface, and because of this, it significantly affects the dwarf planet's rotation. You can achieve a similar effect by attaching something heavy to one side of a rotating object, like a frisbee. According to scientific models, this is how the large glacier ended up directly opposite Charon. One theory suggests that the hidden mass beneath Sputnik Planitia is an ocean, which isn't an absurd idea. Data from the New Horizons spacecraft showed that both Pluto and Charon are complex celestial bodies with signs of recent geological and tectonic activity, indicating the existence of a subsurface ocean on Charon in the past and the possibility of one on the dwarf planet even today. So, could life theoretically have evolved on such a distant, cold planet? On Earth and the Moon, seismometers track waves generated by events like earthquakes. The speed at which these waves travel through different materials tells us about the composition and structure of the internal layers of a celestial body. Similarly, during a medical examination using ultrasound, sound waves are used to create images of a person's internal organs. The waves reflect differently depending on the density of the tissues they encounter, allowing doctors to see internal organs. However, on distant worlds where there are no seismometers, astronomers speculate about the composition of the layers based on the density of the celestial body. They can build models based on the most likely materials, such as rock and ice. In one such model, scientists hypothesized that beneath Pluto's surface, there could be a hot, sticky layer of asphalt. Initially, this was organic material like carbon, which, under extreme pressure and temperature, could turn into a thick, tar-like substance. Kuiper belt objects usually contain lots of organic material, and if Pluto's crust also had some of this material, over time, it could have transformed into a 100-kilometer thick internal organic layer. Depending on the conditions inside Pluto and its chemistry, the layer could be in the form of liquid asphalt or solid carbon, like graphite, and it could be mixed with a liquid subsurface ocean. But how could a planet billions of miles from the sun keep this water from freezing over such a long time? Billions of years ago, pieces of rock, ice, and dust gradually came together to form Pluto and other objects in the solar system. When the dwarf planet reached a sufficient size, residual heat from its formation could have melted chunks of ice that make up part of Pluto. This theory works well if we assume a hot start. But how can we be sure that Pluto started out hot or cold? When liquid water reaches a certain temperature, it solidifies, creating cracks on the surface. This happens because water expands as it freezes. You can test this by filling a glass with water and freezing it overnight. In the morning, you'll find that the glass is cracked due to the pressure released as the water expanded while freezing. Something similar happens on Pluto, but much more slowly. Frozen water is also less dense, which allows ice to float in liquid water. If Pluto had a hot start, it should show clear signs of this. Its surface would have expanded and cracked as it gradually cooled. And if the dwarf planet started out cold, astronomers would expect to see signs of past compression on Pluto. New Horizons showed scientists craters on Pluto that are almost as old as our solar system, and none of them are compressed. In one study, where researchers theorized the presence of an ocean beneath Sputnik Planitia, they suggested that it might be filled with a large amount of ammonia. If this turns out to be true, the subsurface ocean wouldn't be like liquid water, but more like syrup. The ammonia in it would be colorless and have an intense, suffocating odor. But what's fascinating is that this chemical compound of nitrogen and hydrogen is one of the ingredients for life. And not only that, when ammonia comes into contact with water, a chemical reaction occurs, and the molecule acts as an antifreeze, keeping the water warmer than it would be otherwise. If other dwarf planets and large icy moons in our solar system started out similarly to Pluto, Earth might not be the only celestial body containing a liquid ocean and potential life within. Our solar system could be a vast reservoir of water, both in its inner and outer regions, with a variety of watery environments. In the scientific community, there's a belief that the evolution of life might be more favorable in a subsurface ocean than on the surface of a celestial body. Even if they are billions of miles from the sun, subsurface oceans can be heated by geological processes, and life in them would be protected from asteroid impacts and deadly radiation. Whether something like this is possible or not remains to be seen in the future. As the probe retreated from the dwarf planet, it took its final high-resolution images of Pluto and its enchanting haze. Overall, the spacecraft made over 200 scientific observations of the Pluto system, including its 5 moons. And now New Horizons is still wandering through the Kuiper Belt after exploring the binary trans-Neptunian object Arakoth. For the next few decades, no other probe will explore this world of icy celestial bodies. And who knows? It might surprise us with another mysterious discovery soon. As technology advances, so does our understanding of the cosmic neighborhood. Do you believe the solar system could be full of liquid water and potential life? Let us know your thoughts in the comments. We read them all. Stay with us for more exciting cosmic discoveries, and thank you for watching.